Welcome. Let's talk about the first law of thermodynamics. Thermodynamics puts things into broad categories. So energy can either be kinetic or potential. And the transfer of energy can take place either via work or through heat. And the first law of thermodynamics, which is the law of conservation of energy, says that if you look at the change in energy in your system and the change in energy in your surroundings, that has to be equal to zero. And so when we do calorimetry, we take advantage of the fact that whatever the energy change of the system is, it's the opposite of the energy change of the surroundings. But if we take a closer look at how we can change the energy of that system, then we actually have two different ways that energy change can happen. It can be changed through heat, or it can be changed through work. And when we take a look at these two ways that we can transfer energy, it turns out that neither of these are state functions. So the pathway and the method for your transfer makes a difference. But energy itself is a state function. So it doesn't, as far as the energy is concerned, it doesn't matter how you got there. But the method of the heat and the work does matter. So we need to take a closer look at the heat and at the work, and with some terminology and some sign conventions that we're going to be using. When it comes to heat, which is more familiar to us, we know that heat can be gained by the system, so that'd be an endothermic process, or that heat can be lost by a system in an exothermic process. The same thing holds true for work. Work can either add energy to a system, in which case we say that work is done on the system, or work can be negative, where work is done by the system. In this class, we're only going to talk about pressure and volume work. And if we're talking about pressure volume work, then the definition of work is minus the pressure times the change in volume. And so we're at constant pressure in this situation. If you look at this, if the change in volume is positive, that means the work is going to be negative. And so for what's called an expansion of a gas, work is going to be negative. On the other hand, if a gas is compressed, and so the change in volume for that gas is negative, a negative times a negative gives us a positive value for work. And so for a compression of a gas, work is going to be positive. And what we're going to do is we're going to put these values for Q and for W and this terminology, endothermic, exothermic, work being done on or by a system, expansion and compression, put those together to solve some very relatively mathematically simple problems, like the next example. The work done when a gas is compressed in a cylinder with a movable piston is 462 joules. Okay, first off, here's a picture. So here's my gas cylinder, okay? And this gas cylinder has a movable piston in it. And so this is some sort of device, some sort of disc that's going to close off and keep the gas separate from the surroundings. And this piston is able to slide up and down. So this is able to move up and down depending upon what's going on with the system. So during the actual process, the gas is going to be compressed. And if the gas is going to be compressed, that means that the piston is going to slide down. So when we're done, our piston is going to be farther down and the gas will have been squished into a smaller volume. And so what we recognize here is that this 462 joules that's corresponding to the work, since it's a compression, that means that work is being done on the system. Delta V was negative, and a negative P times a negative delta V makes for a positive value for work. And during this process, there's a heat transfer of 128 joules from the gas to the surroundings. So if I have heat that's going from the gas to the surroundings, Q is going to be negative as well. Or Q is going to be negative, not as well, but Q is going to be negative in this situation. because the gas is going to be losing energy to the surroundings. And so if I want to calculate the overall change in energy, which is the change in the heat plus the change in the work, since Q is a negative 128 joules, but work is a positive 462 joules, overall, I have a change in energy that is 334 joules.